Nice to meet you all. I am Park Sang-hyun, the head of Maritime PNT Research Office. Today, I would like to talk about the trends and prospects for securing resilience of maritime PNT. Location information, navigation information, and many other kinds of information are to be acquired on the sea. And where do you get the information? You may answer, we get the information through GPS or GNSS, satellite system. The global satellite system that we use includes GPS of the US, as well as the GPS operated by Russia and the EU, and also by a country that is close to Korea, China. China is offering BDS service, which is also called BIDO. These are the global and regional satellite-based systems. These four systems are all offering the global satellite services. And on the slide, we have the NAVIC of the India and QGS of Japan. The services provided by India and Japan are offering regional satellite services. So what we want is a 24/7 seamless service that is available across the world. So these are the representative systems we use for PNT. Last week, Korea launched the Korean satellite, Naru satellite. So that is also a positive signal, and we started developing KPS, Korean Positioning Satellite System. And from 2035, Korea will actually have the KPS system in place, offering satellite navigation system. For now, the GNSS approved by the IMO includes the GPS of the USA and the Galileo of the EU and BIDO of China and so on. In the MEPC meeting last week, QGS of Japan was also approved. So Japan's system will also be able to be used on the ocean. There are 24 GPS satellites, and this is the picture of the satellites that are operating over the Earth. Now, over 140 satellite systems are being operated over our head. We have at least from 60 to 70 satellite-related systems. As such, we can easily get location information through the GPS. And why are we talking about resilience of these systems? The global navigation satellite system has vulnerabilities. For example, the global navigation satellite system is vulnerable to jamming. From 2010 to 2016, we went through 4 times of jamming. And due to the jamming incidents, we suffered a lot of losses and damages. In 2016, in all coastal areas of Korea, in the Western Sea and Eastern and Southern Sea, we experienced the jamming attack, and SOLAS vessels and non-SOLAS vessels, like fishing vessels, suffered damages and losses due to these jamming incidents. And communication systems and navigation systems were disabled by the jamming attack. And how are we going to prepare ourselves to respond to these jamming attacks in the future? Many such incidents took place in other countries. On the left side of the slide, you see the announcement made by the Homeland Security Department of the US. This is a port in the US. Nowadays, most of the ports are automated, so cranes automatically do the loading and offloading jobs. All those loading and offloading systems are based on GPS system. And due to the jamming attack, or because of the inability to receive GPS signal, the cranes were not able to operate. So in the container, there was a luxurious sport car, and in the sport car, there was a jammer because the car owner didn't want the car to be tracked. Rather, the car was actually a stolen car, and the thief didn't want the car to be located through the GPS system, so there was a jammer in the car, and that jammer caused disruptions in the activities of crane at the port. And near the Northern Sea, there have been a lot of incidents of jamming and signal disruptions. Then, is jamming attack a difficult one to do? No, that's not it. It's not difficult to start the jamming attack. I googled a jammer on eBay. As you see here, you can easily find a jammer that can be easily inserted into your car. You can easily purchase a GPS jammer. And moreover, the jammer disables the GPS satellite system. It also has the risk of spoofing. So there's a spoofer on the right side of the slide. This is what happened in 2015. There was a hacker conference in Las Vegas. In that conference, GPS spoofer was discovered and presented. Then we already experienced GPS jamming, so we know what it is about. And can GPS signal be changed with another signal? Yes, that's possible. On the right side, rather on the left side, there's a vessel, ocean-going vessel, and it wants to know the AIS information, and it saw other vessels located near near itself, but it couldn't see any vessels around itself. Although in the AIS there were the marks and signals that there are vessels around that ship. So they captured the GPS screen and sent this to MIT in the US. The conclusion is that there was GPS spoofing. There was a problem with the GPS information because the location information on GPS on the screen has some abnormal information. Location of the vessel is actually the antenna height is minus 39 meters. It means that the vessel is located under the sea. It's strange. And secondly, the GPS signals, the intensity of the GPS signals are similar to each other, but that's not true in reality. And in 2020, various spoofer incidents took place. In California, there was circle spoofing moves. It was a false information. There was no vessel actually. So this kind of problem takes place because spoofing incident took place. Spoofing means that it manipulates and changes the GPS signal. So we tried spoofing ourselves. The picture you see here is Kodak Theater in the US. I took a photo. As you see, if I take a photo, And if you scroll up, you can see where you took the photo. So I saw where I took the photo. And on the right side, it says that I took the photo in Hollywood. But that's not true. I took the photo in Daejeon, where Crystal is located. This is what happens when spoofing takes place. It means that smartphones also use satellite navigation system, so smartphones are vulnerable to spoofing attack. In the US and in the EU, there have been incidents where they were not able to use the GPS system, and this is the kind of losses suffered by various industries and sectors. So in the maritime sector, how can we enhance the reliability and resilience of PNT, positioning, navigation, and timing? In Korea, we have conducted various research activities related to E-LORAN. We have a video clip related to our research on E-LORAN. The video clip will help you understand what we have been doing. This is autonomous vehicle that runs without driver. So things that you thought was possible only in dream is now happening in reality. Position, navigation, and timing, PNT, is the technology that enables this. Starting from car navigation to military and logistics sector, PNT is being used in wide sectors. PNT relies on GNSS system. In terms of reliability, GNSS is vulnerable. GPS receives signal from satellites, and the intensity of the signal is very weak, so it is vulnerable to jamming and spoofing. It is affected by weather conditions, and these days there have been intentional GPS jamming attacks, which caused failure in the operation of smartphones and disable the fishing operations of vessels on the sea. And the GPS jamming could bring about bigger damage than you may think. And the Republic of Korea decided to make up for the weaknesses of GPS system. One of such effort is to develop E-LORAN that uses terrestrial wave. Even if there's a problem with the satellite GPS system, you can rely on E-LORAN. It receives the pulse signal, which is high output and low frequency, from the locations with a distance of about 100 meters. And within 100 nanoseconds, it can receive and send signals and information. Now, E-LORAN has been developed and it is going through real test trials at Arabet Gilstream. And this E-LORAN is very helpful for making the vessel's operations efficient. In this vessel, we have GPS receiver and GPS and E-LORAN integrated receiver. On the outer of the vessel, we have E-LORAN antenna, which receives the GPS signal and terrestrial wave signals. And in the navigator device on the board, you see the location. First, we will try to disable the device by conducting jamming attack. So GPS signal disappeared on the onboard equipment display, but E-LORAN provided location information stably to the vessels regardless of the jamming attack. Secondly, we used GPS hacking equipment and tried spoofing attack. After the spoofing attack, although the GPS signal looked normal, the GPS signal was being maneuvered by the spoofer. But E-LORAN was not affected by the spoofing attack, it stably provided the location information of the vessels. So, jamming or spoofing attack prohibits the vessels on the sea from identifying the accurate location information, but the use of E-LORAN can prevent such problems. We will establish a new E-LORAN base stations, which will first be applied to the southern sea areas, and it will be expanded to other parts of the Korean Peninsula. And from 2023, it will provide information at the level of GPS. E-LORAN system is based on terrestrial wave. It can be applied not only to vessel navigation, but also to financial sectors and other industrial sectors. That will further enhance the stability and reliability of our public services. And we will lead the standardization of E-LORAN to enhance the local companies' competitiveness in this area. As you saw from the video clip, we have finished developing E-LORAN technology, and the Ministry of Oceans and Fisheries is now conducting test trials of this technology. Then, what is the status of other countries across the world? There's an Axis project in the EU. They conducted feasibility study. So not only the E-LORAN of Korea, but also the maritime communication systems such as the mid-wave beacon and AIS. In other words, the middle wave or VH frequency-based communication infrastructure could be used for the purpose of PNT, and this is being studied. So after Axis project, Armored Baltic project started. So in the Baltic Ocean, they created test beds for demonstration of the technology. In Korea, we are providing the pilot E-LORAN service as well as R-mode service based on middle frequency or VH frequency-based service. So we are developing the relevant technologies. Now the accuracy is about the 20 meter, but IMO's requirement is that we need to achieve 10 meter accuracy or precision. So we are doing our best to develop technology that can meet that standard. And in the near future, you will be able to see the Korean E-LORAN apply to the actual site. And IMO and IALA and other international organizations and stakeholders are working on standardization of this technology.